Good evening guys. Today we are going to understand about the PCA. PCA is nothing but a feature extraction technique in the unsupervised learning. What do you mean by feature extraction? In feature extraction, we reduce the dimensionality of our data set from a higher dimension to a lower dimension without losing the essence of our data. So, what happens is that suppose we have two input independent features F1, F2. In unsupervised learning, we only focus on the input. No output is given to you. We just take our input and on that basis only we just analyze our data. So suppose that here was my F1, here one was my F2, and when I plotted my data, it came out to be like this. Okay. Now, if you will see, the last point here is coming something here, and the last point here is coming something here, and the last point here is coming something here, and the last point here is coming something here. So when you will organize, the variance or the spread of the data on this axis is more in comparison to the variance or spread of the data on this point. Okay. So here we are using the two axes for this purpose. Now suppose I want to represent the data not in two figure. I want only one dimension. So what I will do, I will select another axis. Suppose I selected the axis like this. So you can observe that its variance or its coverage is similar to the this one. So yes, this is the best fit vector which can have the same variance or spread as the initial. Okay. So our job in this PC is the same thing. We have to find this vector only. And how we are going to do this? So first of all, understand we are more considering on a vector that will give me the more variance. So what is the formula of the variance? We all know that the formula of the variance is 1 by n summation I is equal to 1 till n x of I minus x of bar whole square. Now, what do we mean by xi? Now, let me tell you. Suppose I have this line and I have taken this random point from that data set. Now we have studied that in a vector space, a point is can be considered as a point vector. Like this, you can see it has a head and tail. Now, suppose I want to make a projection on this, then we know a formula that the projection between two vectors is a dot b divided by magnitude of the vector on which we are taking the projection. So this will be a, this will be b. Now we are only curious about the direction of the vector which we are going to find. So I have assumed as a to be a unit vector. So my projection will be equal to a dot b. Okay. Now suppose this a is something x1 x2 and this b was a vector y1 y2. So on doing the dot product we know that it will be x1 y1 plus x2 y2. So this projection will be coming out something here. This is a scalar value. We all know that when we find our dot production we get some scalar value. This length till which I have got my value, this is depicting the projection of my point on this. Similarly, I will do the projections of all the remaining point on the data set on this. Okay. Okay. So now just see here in our data set there will be also a point which will be the mean of the data, and suppose the mean of the data is this point and the projection of the mean point I will be going to put here in the x bar. Now let me tell you about this formula. So what will happen is it will become 1 upon n summation I is equal to 1 till n u transpose, or you can say it a vector, into x of I, or you can say dot product, minus u transpose into x bar whole square. So this will become the formula of our variance, and we have to find such unit vector will maximize this thing, which will maximize this thing or variance value. So Now let me tell you, first we have created here. Now I am going to tell you about the covariance matrix. So what is a covariance matrix? First of all, understand about covariance. What do we mean by covariance? The covariance between 2 points gives us the relation between 2 points. If the covariance between 2 points is positive, then we say that these are directly proportional. If we increase one value, then other will also increase. If we decrease one value, the other will also decrease. Okay. So how we calculate the covariance between two features? Here we have f1 and f2. So it will be what? If we have our two features, then it matrix is also 2 cross 2. It will be variance of f1, variance of f2, covariance of f1 comma f2, and the covariance of f2 comma f1. Okay. And when you will use the formula for variance and covariance, you can easily get the numerical values here, and this is our covariance matrix. Now what we will do is the eigen decomposition of this covariance matrix. We are going to solve this by the characteristic equation. Suppose this is we say it C, let's say it's C. So C minus lambda I is equal to 0. On solving this, we will get some values of lambda. Since here two features are only possible, so we will get lambda 1 and lambda 2. And by the use of this lambda and 1 and lambda 2, we are going to find our eigenvectors. Okay. So since here two features are only possible, so we will get our two eigenvectors for the value of lambda 1 and lambda 2. Now suppose our lambda 1 was greater than lambda 2, then what will happen, that we will observe that the eigenvector which will be coming on putting the lambda 1 will have more variance in comparison to the covariance factor which will come by using the lambda 2. In the research also it is found that the eigenvector for which the lambda value is greater, it covers more variance or spread, and the vectors which comes here are only called the principal components. Here it will be principal component 1 for lambda 1 value and principal component 2. And at last what we do? At last nothing but we put our eigenvectors in a matrix PC1, PC2. Then we take transpose of this matrix and we multiply it with the input feature data points. And on doing this, we are complete with the transformation of our data, and we keep that much principal component in the W vector or matrix in which number of dimensions I want to keep my final data. Thank you.